Here we have been asked that which of the following molecules are non-polar in nature. Now the basic concept says that non-polar molecule is a molecule in which the vector sum of the dipole moments of all the bonds is equal to 0. If the vector sum of the dipole moments is not equal to 0, the molecule is said to have a certain polarity and thus it becomes a polar molecule. The approach to solve these types of questions is to make the structures on paper and then to examine the vector sum of the dipole moments of all the bonds. So the first compound is ammonia, and ammonia has a non-planar structure and the dipole moments can be shown as follows. The vector sum is not equal to 0 and thus this is a polar molecule. Carbon dioxide molecule, what happens is that the bonds themselves do have a dipole moment, but both the dipole moments are equal and opposite in nature, and thus the net or the vector sum of the dipole moment is equal to 0, giving a non-polar molecule. In the water molecule, the hydrogen oxygen bonds, they have a dipole moment, but the vector sum of the dipole moment is not equal to 0, resulting in a certain polarity. CF4 molecule is a tetrahedral molecule and the CF bond is polar by nature, and the bonds can be said to have an individual dipole moment represented in the following manner, but the vector sum of the dipole moment is going to be 0, giving a non-polar molecule. When it comes to the bromine molecule, which is a diatomic molecule composed of two bromine atoms, there is no difference in the electronegativity of the two bromine atoms, and thus this is a non-polar molecule. BF3 is a planar molecule and the angle between two boron fluorine bonds is 120 degrees. Here the BF bond does have a dipole moment which can be represented in this manner, but the vector sum is going to be 0, resulting in a non-polar molecule. CH2Cl2 has a tetrahedral structure and there are dipole moments. The vector sum of these dipole moments is not equal to 0, giving a polar molecule. Hydrogen peroxide has an open book structure which is non-planar, hence the dipole moments do not sum up to 0, giving us a polar molecule. Hence what we can say that the following organic compounds, which are going to be carbon dioxide, bromine, CF4 and BF3, these are going to be non-polar. Hence on analysis of the given options, we understand that option A is the appropriate answer to this question.